we're going to use those concepts and then try to figure out how much fertilizer or how much nutrients are coming from the different components that are there in our field. We want to do a soil test first. We want to know what's there in the soil to begin with. And so once we get the reports back, we can figure out what else needs to be added. We have added some concepts here that might not be applicable to everybody, but we wanted to cover them today, and the calculations are there in your handouts as well. For example, if you have somebody that's growing crops organically and they use compost, if you have somebody that's using organic production and uses cover crops and compost, or if it's conventional, soil test, cover crop, and then your actual cash crop, for instance. So some of these concepts we'll be going over today, and the calculations are there in your handouts. So based on what the levels are from your soil test, you can always go back to your production guide, and all the production guides or the information for each vegetable type is available online on EDIS as well, as you all know. So look at the tables within that each crop guide, and depending upon what the levels are in your soil test, if it's very low, medium, high, then you have the corresponding recommendations for your phosphorus and potassium application. We don't have recommendations for nitrogen, and that's because nitrogen tends to be in a very mobile form. So it might be in certain amounts today. It might not be the same case down the line a couple of days later when you could actually be doing the planting. So for nitrogen, we have more of the standard recommendation rather than based on a range. So same thing here, you want to take into consideration what the plant spacing is. If you're planting standard watermelons on 8-foot centers, then the amount of nutrients that is required to be applied is going to be quite different than if you're planting mini melons on 4-foot row centers. They still need the same amount of nutrients per plant basis, but because you have a lot more plants per acre, your amount of fertilizer to apply per acre is going to be different. And so make sure that you know what your plant spacing is so that you have to adjust your amount of fertilizer being applied if you're using row spacing that's different from the standard, which is your 6-foot for tomatoes, for example. So here is a pictorial representation of what the recommendations are for the different crops. For example, here watermelons, how much to apply on a per week basis throughout the crop growing cycle, both in nutrients and as well as water. So it kind of gives you an idea as to, based on the stage of the crop, how much you would apply so you're meeting the plant's water needs and their nutrient needs. So the crop nutrient requirement can come from different sources. Inherently, because of the organic matter in the soil, some nutrients can come from the soil itself. If you're adding a compost, then from the compost. If you have a cover crop that you're tilling under, then some nutrients are going to come from your cover crop. But whatever's available through those three resources, then you got to look at what's remaining and then put in the fertilizer. So we're going to go over those calculations now. So we're going to look at crop nutritional requirement, contributions, and fertilization. If you're not taking into consideration how much water you're applying to the plants, then the potential of leaching your nutrients is going to be really high if you're applying too much water. So make sure that you're taking into consideration your irrigation practices as well when putting together a crop nutrient management plan. So this is where we start off. We don't have anything figured out yet. We're going to add numbers as we go through the different calculations. So we want to get our soil test report back, and then we'll add information as we go from each step here. For this exercise, we're going to consider that we have a sorghum Sudan cover crop, and the results came back that the nutrient analysis of this cover crop was 1.5% nitrogen, 0.2% potassium, 0.2% phosphorus, 2% potassium, and a nitrogen mineralization rate of 23%. Availability of 70% of phosphorus and 80% of potassium, and the biomass yield was around 9,800 pounds per acre. So let's do the math. The moisture percentage was how much? 10%. So first we're going to figure out how much dry matter is there in this particular cover crop that we're tilling under. So 9,800 pounds per acre, so that's the biomass. And so we multiply that times 0.9. That gives us then a dry matter content of 8,820 pounds per acre, right? Everyone here with me? All right, next, based on the dry matter amounts is when we're going to figure out what the nutrient contribution is from our cover crop. So from our tables, we know that sorghum Sudan has 1.5% nitrogen, 0.2% phosphorus, and 2% potassium. So nitrogen levels are going to be 8,820 times 1.5 by 100. That gives us 132 pounds of nitrogen. Phosphorus, again, it's phosphorus percentage, not the P2O5. So that's where we're multiplying that with the 2.29. So 8,820 times 0.2 by 100, that gives us 18 pounds of phosphorus times 2.29 gives us the P2O5. Same thing with your potassium, 8,820 times that 2% of potassium in your sorghum Sudan grass. That gives you the total pounds of potassium, not K2O. Multiply that times 1.2 gives you the pounds of K2O contribution from your cover crop. Let's go ahead and write that into our table. So our cover crop is giving us 132 pounds of nitrogen, 41 pounds of P2O5, and 212 pounds of K2O. Now, is all of that going to be available for the next crash crop we're going to plant? No. So that's where our second table comes into play. We're going to look at the mineralization rates. We know what is out there, the total amount that's there in that cover crop, but not all of it is going to be plant available for the next crop. So for sorghum Sudan grass, the mineralization rate was 23% for nitrogen and 70% for phosphorus and 80% for potassium. So let's go ahead and do the math again. So nitrogen total was 132 times 0.23. That gives you 54 pounds of nitrogen per acre that's going to be available for the next cash crop that you're going to plant. Same thing with your P2O5. 18 times the 70% times 2.29 gives you the actual P2O5 and not just the phosphorus. And K2O is the same. So everybody figure that out. So instead of just what is available to the crop at that point, that's what we're doing the calculation here for, rather than the total amount of nutrients from that entire biomass. Make sense? Okay. Let's go and put that in. So now we know that for our crop nutrient requirement, 54 pounds of nitrogen is coming from our cover crop, 29 pounds of P2O5, and then 169 pounds of K2O is going to come from our cover crop for this season. So again, remember that total does not always necessarily mean in a plant available form, whereas available means what's available for the plant to uptake that's going to follow the cover crop. Also take into consideration that your row spacing or your the bed spacing that you have, because you're spreading out the cover crop on an entire acre rather than the modified broadcast like we were talking about earlier, not necessarily everything that's there in between the alleys is going to be plant available. If you could spread press where you're picking up everything from the alleys and putting it into the bed, is when the actual amount that is in the entire field is under the crop. So let's say you have a field that only from one bed to the other is 5 foot centers bed spacing, then you're losing some portion. So we want to apply a general amount of 5 tons per acre of compost. And we know it costs around $40 a ton and $10 for spreading and transporting. The fertilizer analysis, which is usually on a dry matter basis, you want to dry weight basis, you want to pay attention to this, is what you would get if you sent your compost sample in for analysis to the soil testing lab. And they give you the levels of nitrogen, phosphorus, and potassium. So our results came back saying that nitrogen was 2%, phosphorus was 1%, and potassium was 1% on a dry weight basis. So what was the moisture levels in that compost sample? 30%. So when we do our sample analysis later on, we need to take that into consideration. The depth to which we're going to incorporate this compost is going to be the root zone for typical vegetable crops. As you want to keep it within that top 12 inches. So if you're doing a broadcast application, you're spreading this 5 tons of compost over the entire real estate acre, which is your 4,560 square feet. So basically, we're applying around a 1/4 pound of compost per square foot. How much does this application cost? it's going to cost us approximately $250 per acre based on our assumptions earlier. Now we want to figure out how much nitrogen P2O5 and K2O does this compost analysis provide. So we know what the fertilizer analysis is on a dry weight basis. So go ahead and do the calculations. So if you're doing 5 tons, and this is 2,000 pounds, 5 times 2,000 pounds times 0.7 gives you 7,000 pounds of dry weight of your compost. Make sense to everyone? Okay. For ease of calculation here, we have shown it to you as 70 times 100 because then it makes it easier for all those percentages of nutrients that we have. All right, so we have around 70 times 100 times 2%. So your nitrogen contribution is going to be 140 pounds of nitrogen. Your phosphorus is 70 times 1 because that's your 100% there. And then times 2.29 where you're converting it into your P2O5. So you have around 154 pounds of P2O5 coming from your compost. For K2O, same calculation, 70 times 1%. That gives you 70 times 1.2047, which is your conversion factor into K2O. So a total of 84 pounds of K2O is coming from our compost. So now we know that this is how much we're getting from our compost. Is it all going to be plant available immediately? This is the total amount. Right. So that's something we need to think about as well. Another thing you want to think about too, we're doing a broadcast application over the entire field, not necessarily just in the rows that the plants are going to be planted. Just for ease of calculation, that's what we did here today. But if you're doing a modified broadcast, then you want to put it in the row so that you don't have fertilizer from this compost leaching where you don't have plants, where you don't have rows. All right, are the crop roots having access to all the compost? What will happen to the nutrients from the compost that fell between the rows? Are all the nutrients available to the first crop? So these are things that we want to think about. So if we grow cantaloupes on 28-inch wide beds and rows spaced 5 feet apart, only 2.3 by 5, which is 50% of that compost, is going to be under plastic. So if you did a overall broadcast and not the modified broadcast like Dr. Simone talked about earlier, then inherently we're going to lose half of our nutrients that the plant is going to have available to it. So let's go ahead and do that deduction there. And this is assuming that you're not being the right type of farmer. You know, you're not doing your modified broadcast. So that's what happens then. So you, instead of the 140 pounds of nitrogen, then the plant has only 70 pounds of nitrogen that is available to, or total amount that is that it can get in touch with. But not all of that 70 pounds is going to be immediately available for uptake by the plant. So typically 50% of the nutrients from a compost are going to be available for the first crop after the compost has been applied. So if you're looking at 70, now you're looking at 35. So out of that 140, if you weren't judicious in the way you applied your compost, didn't do modified broadcast, you lost 50% just from putting it in the row middles. And because only 50% of what's available totally is going to be available to the plant, so you do a half, 70 by 2, that gives you 35 pounds of nitrogen that's plant available from that 5 tons of compost we applied, 36 pounds of P2O5 that's plant available, and then 21 pounds of K2O that's plant available. If you're growing snap beans, a different example here on 18-inch row spacing, and the roots grow 6 inches on each side of the plant, then we're looking at 1 by 1.5, which is based on your plant spacing. That gives you 66% of the compost is being used by the plant, as compared to 50% earlier. So this is a bit more efficient system, but you're still losing nutrients from the compost not being used up by the plant. So how much is accessible to the plant? 66% of the 140, 66% of the 154, and 66% of 84. So the plant can access this amount of nutrients, but we know only 50% is plant available. So let's half that. And that gives us 46 pounds of nitrogen 51 pounds of P2O5, and 27 pounds of K2O that is available to your bean crop. Okay, so what are the lessons we learned so far? Broadcast application is easier, but there is inherent risk of losing fertilizer that's within your row middles, for instance. We also learned that only 50% of the nutrients are going to be available from compost for the first crop. And also based on compost mineralization, only 50%, about 50% is going to be available for the second crop. So let's say you have, what was it earlier, 140, and then half of that for the first crop, then that 70, a half is going to be available for the second crop. And 70 minus 35, so a half of the 35 is going to be available for the third crop. So basically you're doing halves for subsequent crops. Okay, so here's the easy way to represent that information. So if you're applying compost, the first crop is going to get 50% of those nutrients available to itself. The second crop is going to get 50% of the remaining, so 23 pounds. The third crop is going to get 50% of the remaining from the second crop, which is around 12 pounds. So on and so forth, you know. So if you thought you put compost today and you didn't have to think about it in your calculations for the next crop, it doesn't work that way because it's still there in the soil. So hopefully we're doing a soil test so we know what the contribution of nutrients is coming from the prior application of cover crop or compost. What is the nitrogen contribution of the mineralization of the organic matter? All right, so our soils have organic matter too. And once they're broken down by the microbes, what do they release? Nutrients to our crop. So it's important that we analyze our soils so we know how much organic matter is there in our soils, and then we understand how much of the nutrient contribution is coming from the soils. Typical Florida soils, what percentage do you guys see? Not a whole lot, right? Maybe 1%, maybe 2%, but typical conventional fields, not a whole lot. So in our example here, we're going to assume that our soil test result came back saying that our soils have around 1% of organic matter. Usually organic matter contains 1% nitrogen, and it decomposes at a 10% rate. The amount of P2O5 and K2O is quite negligible, so that's less calculations that you'll have to do when trying to figure out where your different nutrient sources are coming from. So our soil, it's around 2 million pounds. Don't ask me how I got that number. Ask Dr. Simone, he put it in there.
I believe it. It was exhausting.
So he took this really huge balance and figured it out, like, so got the 20,000 pounds of organic, so multiply that times the percentage organic matter, so it came out to 20,000 pounds of organic matter in 1 acre. So like we saw earlier, only 1% of that is nitrogen, so 20,000 times 0.01 comes to around 200 pounds of nitrogen to the acre. But again, the release rate or the decomposition is at 10% rate, so only 10% of that 200 is going to be available to your first crop when you did that soil test. So 200 times 0.1 gives you 20 pounds of nitrogen that you're going to get from that organic matter that you have in your soil. But again, keep in mind that, you know, all that 20 pounds is not necessarily in the bed that your plastic mulch is covering. There's some in the row middles too. So if your beds cover 3/5 of the field, then plants will have access to only the 3/5 portion of your 20 pounds. So that's around 12 pounds of nitrogen from mineralization of the entire field. Okay, we have another number to add to our table to come down to our final tally that we need to figure out from fertilizer. So we figured out how much we got from compost, we figured out how much from cover crop, and now we know from organic matter, we're getting around 12 pounds per acre and very negligible amounts of P2O5 and K2O.